So the lesson today is on tangent lines of circles. And if you look at the circle on the board, you will notice what a tangent line is. A tangent line is um, right against the circle. So a tangent line goes beside a circle. It goes right beside the circle and touches the circle. So you see it touches the circle there at point P. Um, and so let's read what a tangent line is. So tangent to a circle means a line in the plane of the circle, so that just means it's going near the circle, that intersects the circle in exactly one point. So it intersects the circle, meaning it touches the circle at exactly one point, right there. So the way we say that is we could say segment AB, so from A to B, is tangent to circle O. That's a way of explaining that. And the point of tangency is where it touches the circle. So the point where a circle and a tangent line intersect. So point P is the point of tangency on circle O. So right here is where the tangent line and the circle intersect right here at point P. Okay, so that's the very beginning of the notes. As we move down, the first thing we have a theorem to talk about. A theorem, again, is just something that we know is true, but we're showing how we know it. So if a line is tangent to a circle, then it is perpendicular to the radius. So an example of that is right here. The line RS is tangent to the circle, which means it is perpendicular right here, makes a 90-degree angle to the radius from P to R. So PR and PR and RS are perpendicular. The way they show the word perpendicular is with that symbol. Okay? So that symbol means perpendicular. It's like a line straight down and straight across. It's like showing that one line goes across and one goes straight up and down. All right, that means perpendicular. So if that's a tangent line, then they are perpendicular to each other, which means they make a right angle, which is going to be important when we're trying to solve things in just a little bit. So in example number 1, we want to find the measure of x. Okay, so to find the measure of x, we've got to know a couple things. First of all, we know that this is a tangent line. Okay? And we know that this is the radius. So we know that this creates a right angle right there in example 1. It makes a right angle, a 90-degree angle. Now, if this radius is 8 right here, what is the radius from here to the circle? If from C to B is 8, what is it from C to D? It's also 8. They're both radius. They both are a radius of the circle. So that whole side, all the way from A until C, that whole side is how far? 17. It's 9 plus 8, so it's 17, right? So anytime we have a right triangle, we can do what's called the Pythagorean theorem, right, to solve the missing sides. So the Pythagorean theorem is a squared plus b squared equals c squared. The a and the b have to be the legs of the triangle. The legs of the triangle are the two sides that make up the right angle. So that would be x and 8. X and 8 are the two legs. So let's say x squared plus 8 squared equals, the hypotenuse is your c, that's 17 squared. And we're trying to now solve for x. So we're going to subtract the 8 squared over. X squared equals 17 squared minus 8 squared. Okay? Don't make the mistake of thinking 17 squared minus 8 squared is just 9 squared. That's not right. You got to use your calculator. Okay? So 17 squared minus 8 squared, we would go and put that into the calculator. And 17 squared is 289, and 8 squared is 64. So 17 squared minus 8 squared gives us 225. 225. And then to find x, we just take the square root of that. So we say, what is the square root of 225? And we just have to put that in the calculator again. We say square root of 225 is 15. So x is 15. And we're done with example 1, part A. So we had to know it's a right angle. That made it a right triangle. And then we can use the Pythagorean theorem to find the missing side. That's all we had to do. All right. We're going to do the same thing here in B. Okay. So you're not going to see one like that in B, but that's how you would set it up. X squared plus 9 squared equals x plus 6 squared. So it would be a squared plus b squared equals c squared. So you would have this one squared plus this one squared equals all of this squared. Okay, so I'm just going to set that one up. We're not going to go and solve that one because I don't want you to freak out over one that you shouldn't see. You should have the numbers there for you. All right? If that was a multiple choice question, you could plug the number in for x and see which one works. And part B is an example of one that could be a multiple choice question that you would see. Okay, so let's go to example number 2. Let's move down to example 2 and example 3. Let me erase that other part off the board for you, and we'll move forward. We're just looking to find x. If we notice here, we have a angle that is 152 degrees right there. All right, both of these are tangent to a radius. So these are right angles, 90-degree angles. If we go like this, we can actually make that into 2 triangles, okay? And half of 152, so let's say we cut 152 in half. Half of 152 is 76. So we can say there's 76 degrees up here, and there's 76 degrees down there. So we got 76 in each triangle, okay? So just think of it like it's 2 triangles. There are 2 triangles. The measure of this angle is what? Right here. 90. This one's 76. So what does the one down here have to be? They all 3 have to add up to 180, right? So if you know that one of them is 90 and the other one is 76, then you can find the one that's missing. So you subtract them from 180. So if we know that one of them is 90, one of them is 76, the last one is just going to be 14 right here. If you know this one's 90, this one's 76, then this last one is just 14. So what is the measure of this angle here, down here? It's 28 degrees. Okay. A little tricky there, a little bit of work to do, but not too much. Okay, let's look at the next one. This one's even easier. This is a 90-degree angle. You have to know that because we have a tangent line and we have a radius. Anytime a line that's tangent and a radius, it says that they create a 90-degree angle because they're perpendicular. So we know this is 90 degrees. We know that's 38. So 180 minus 90 minus 38 is going to equal x, the one that we need. So we subtract 90 and 38 from 180. Anybody got that? 52. Yep. So 52 degrees is the missing angle. So you have a 90-degree angle, 38-degree angle, and a 52-degree angle. Perfect. All right, last one. Example on this first page. Example 3 says, is segment MN tangent to circle O at P explained? So basically, we're trying to figure out if this works or not. Can we do the Pythagorean theorem or not? Okay? Because this should be a right angle. And if it's a right angle, we should be able to do the Pythagorean theorem. So this right here is 5. So what is this part right here? 5. Okay? So this whole side, the hypotenuse, is how long? 18. Right? So we have all three sides. We're going to see if it works. That's how we prove if it's tangent or not. Does the Pythagorean theorem work? A squared plus B squared equals C squared. All right, let's try it. So A squared, we use our two legs. 12 squared plus 5 squared equals 18 squared. Let's see if that works. 12 squared is 144 plus 5 squared is 25 equals 18 squared. 144 plus 25 is 169. What is 18 times 18? I have my calculator. 18 squared. Yeah, not that, right? So 18 squared is 324. So does that work? So we'll say no. Those are not equal. So the answer is no. So the Pythagorean theorem's got to work for it to be tangent. Like it should work. We should be able to do a squared plus b squared equals c squared. We tried it by plugging in all the numbers. And when we plugged in the numbers, we got something that didn't work. So that means it must not be a tangent line. It must not be right. So that's a way to check if the line is tangent. That means does the line actually go to the circle and just hit the circle at one point? So we're just checking our work there, and we are able to see that no, it did not. Instead of, in the first page, like I said, we learned that a tangent line and a radius make a 90-degree angle. And in a triangle, we have three angles that add up to 180. Or we can learn from that we can use the Pythagorean theorem to find the missing sides. So we could find the angles or the sides. Now, we're looking at two tangent lines, okay? So if you have two tangent lines, it makes it look like a cone, actually, right? If you have two tangent lines that meet at the same point, then guess what it tells us about those? They are equal. They are congruent. So if from N, look at example 4 right here. From N to P, if this is 12, what is this? Man, what an easy one for us right there. X equals 12. That's all we had to do there. So that was a great one. I wish they were all like that. Right? Now, what we get into is where we have to solve the equations. So if PW is 3x minus 6, then QW is x plus 10. It means they're equal to each other. So we have to say 3x minus 6 equals x plus 10. So we go back, just like we have in almost all the units in Math 3. We end up, at the end of this, no matter what we're talking about, circles, quadrilaterals, anything that we've talked about so far, we end up, absolute value, any of our earlier units, we end up with an equation at the end. And so we're just trying to solve for x. So we're going to subtract x. So we get 2x. And then we can add 6 to the other side. And we get 16. Divide by 2. And x is what? X equals 8. Now, what I would encourage you to do, just to make sure you don't make a mistake, take the 8, go back and plug it in and make sure it makes them equal. So if x is 8, 8 plus 10 is 18. So this line is 18. If x is 8, 3 times 8 is 24. Minus 6 is 18. So that line would be 18. So they work. So I know that the 8 that I got is the correct answer. There's no doubt in my mind when I submit the answer that it's right, because I went and just plugged it in just to see if it made the two sides equal to each other. Okay? Same thing here, A to B and A to C. If the two sides are equal, we just set them, if the two sides share this point here, we just set them equal. So 4x plus 2 equals 2x plus 8. Again, I usually take my smaller x and move it over to the bigger one, just so I keep it positive. It doesn't matter, but that's usually what I do. So I subtract the 2x. So 4x minus 2x is 2x. And then I'm going to subtract the 2. And 8 minus 2 is 6. So I end up with 2x equals 6. And so x equals what? 3. So x equals 3. Now, if x equals 3, 4 times 3 is 12, plus 2 is 14. 2 times 3 is 6, plus 8 is 14. So both sides are 14. So just like in the last one, we found both sides were 18. In this one, if you plug in 3, we find that both sides are 14. So they match. They're equal to each other. We know we did it right. We know we plugged it in right. We know the answer is right. So there's no confusion as to whether we did it correct or not. So in this case, it says circumscribed versus inscribed. Circumscribed is when you draw a figure around another one, touching it at points as possible. So it says the circle is circumscribed about the triangle. That would be that picture over there. Take the circle and put it around the triangle. And see, it touches the triangle at all 3 points. To inscribe is to draw a figure inside. Think about inscribe. That means inside. Inside of the circle. So the triangle is inscribed in the circle, is that example. So circumscribe, that comes from the word circumference. Circumference means all the way around. So that would be putting it on the outside. Inscribe means you're drawing it inside of the other figure. So notice this theorem right here says when a polygon is circumscribed, so that means any shape, a polygon could be any shape, right? Is circumscribed, so that means on the outside of a circle, all the sides of the polygon are tangent to the circle. That means they all touch the circle there. If you look at B to C, you see it touches the circle. A to B, you see it touches the circle. A to F touches the circle. F to E. G to H, you see it touches. G to K, it touches. K to J, H to J. So it's showing you no matter what shape you draw around the circle, it's going to touch that circle every single line. So now, what does that mean? Well, let's look at it. So it says, example 5, triangle ABC is circumscribed around circle O. So that means it goes right around circle O. Find the perimeter of the triangle. Now, the perimeter means what are we trying to find? Yeah, all the way around it. So we're going to add them all up. Well, there's a couple things we don't know. But we do know it. If B to E right here is 6, what is B to D? 6, right? If F to C is 8, what is C to E? 8. If A to F is 12, what is A to D? 12. And we learned that earlier on the page. At the top of the page, we learned that they had to be equal to each other if they go to the same point, right? So now, if you look at that triangle, we actually have all this, we have the whole thing. We have 12 plus 12 plus 6 plus 6 plus 8 plus 8. So we have every part of that triangle. We have this is 12, we have this is 6, this is 6, this is 8, this is 8, this is 12. So we can find the perimeter of the triangle. What do you get if you try that? Anybody? 52. So 52 is the perimeter. 12 plus 12 is 24. This is 12, that's 36, and this is 16. So it is 52. So that's the perimeter in example 5. Okay? Now, let's go to the bottom. Last 3 questions that are on here. Let's look at that. On the last 3 questions, it says, find x. Well, very simply, you're just piecing together things you already know. This is 8. So down here would be what? 8. So this whole line would be 16. And that's what x is, right? That's what x is looking for. So x is equal to 8 plus 8, which is 16. So we got that. Now we could try to piece together the other part. This is 2, so we know the other side's 2. This is 4, so we know this is 4. This is 6, so we know this is 6. So what is x? 10. Yeah, it's just 6 plus 4, which is 10. It's like piecing together a puzzle again. We're just looking at things. They give us things that are true, those theorems, and we use them to piece together the puzzle. So in here, this is 3, so this is 3. That's 1. Don't forget this one. A lot of people forget this one. If that's 1, that's 1. That's 2, so this is 2. That's 6, so this is 6. They could ask you to find the perimeter of the whole thing if you needed to. But all they're looking for in that one is x. So what is x down there? 8. So x equals 2 plus 6, which means it is 8. And that's all we're looking at today. So 3 things that can happen. Number 1, 4 things. Number 1, you can get a right angle. And you may have to solve for one of the angles, knowing that they got to add up to 180. So you may have to subtract the other angles from 180. Number 2, you might get 2 lines that make it look like a cone. In that case, you set them equal to each other, and you solve for x. And then, number 3, you may get a shape that is outside of the circle. And the shape, you can find the perimeter of it. If you know one side, you know the other, because they have to be equal, those things on the shape, just like they had to be when you had the lines going outside. So we use the things that we know to piece together the shape and get the measurements that we need to get our final answer. So the work today is going to be on this. There's a tangent line IXL. So we're going to go to it. You get to a 90 and you're done. If you miss one on the IXL, go down, look at the feedback. Don't miss, a bunch in a row. Go down and look at the feedback, because it really should not take you more than 30 minutes. If it does, you're doing something wrong. You're not checking the feedback to make sure you get it right, because it'll tell you what you're doing wrong and how to do it correctly. So you may want to write one of the examples down that it says if you miss a certain problem, so that you don't miss it again. But that's the IXL for today, and that's your classwork that you'll have to finish today.